Kasediye.
The concept of the apocalypse has fascinated humanity for centuries. Found in religious texts, myths, literature, and movies, the apocalypse is often portrayed as the ultimate end of the world, an event marked by cataclysmic destruction and the collapse of civilizations. But will the apocalypse actually happen? To explore this question, we must consider perspectives from theology, science, and philosophy. Religious traditions have long prophesied apocalyptic scenarios. In Christianity, the book of Revelation describes a dramatic end involving cosmic upheavals, the return of Christ, and the establishment of a new heaven and earth. Similarly, Islamic eschatology foretells the day of judgment, while Hinduism speaks of a cyclical destruction and rebirth of the world. However, theological interpretations of these prophecies vary. Some view them as literal events that will occur at a specific time, while others see them as symbolic representations of spiritual truths or moral warnings. The diversity of interpretations underscores the difficulty of determining whether such prophecies predict a tangible, universal apocalypse or a metaphorical transformation of humanity. From a scientific standpoint, several potential apocalyptic scenarios exist, although they are typically framed as catastrophic risks rather than divinely ordained events. These include climate change. Throughout history, climate shifts have contributed to the decline of civilizations. The Mayan civilization. Prolonged droughts played a significant role in its collapse. The Little Ice Age. This period of cooling disrupted agriculture in Europe, leading to famine and social upheaval. The Dust Bowl. 1930s. Severe drought and poor land management caused widespread economic hardship in the U.S. These events highlight how vulnerable societies are to climate-induced stress, even without today's scale of global interconnection. Unlike isolated historical events, modern climate change is a global phenomenon, making its impacts far-reaching. While not traditionally associated with doomsday imagery, climate change carries the potential to disrupt global systems to the point of collapse. Here are the pathways through which it could lead to apocalyptic outcomes. Rising sea levels and submerged cities. Cause: melting ice sheets and thermal expansion due to global warming. Impact: coastal cities like New York, Mumbai, and Shanghai could become uninhabitable, displacing hundreds of millions of people. Apocalyptic outcome: massive migration, resource conflicts, and the collapse of urban economies could lead to societal chaos. Extreme weather events. Cause: a warmer atmosphere holds more moisture, intensifying storms, droughts, and heat waves. Impact: hurricanes, wildfires, and floods become more frequent and devastating, destroying infrastructure and lives. Apocalyptic outcome: constant extreme weather could render large swaths of land uninhabitable, leading to food shortages and mass mortality. Resource scarcity. Cause: changing rainfall patterns and desertification reduce agricultural output. Impact: water and food shortages could become widespread, especially in vulnerable regions. Apocalyptic outcome: global resource wars, famine, and population decline as nations struggle to secure dwindling supplies. Ecosystem collapse. Cause: rising temperatures disrupt ecosystems, leading to the extinction of species and the collapse of biodiversity. Impact: coral reefs die, fisheries collapse, and forests turn into carbon sources instead of sinks. Apocalyptic outcome: the loss of ecosystem services like pollination and oxygen production could destabilize human survival. Disrupted supply chains, reduced agricultural yields, and the cost of disaster response could cripple economies. A combination of crop failures, water scarcity, and ecosystem collapse could trigger famines on an unprecedented scale. Rising temperatures could increase the spread of diseases like malaria and dengue, while heat waves cause direct fatalities. Melting permafrost could release ancient pathogens, potentially sparking pandemics for which humanity has no immunity. Entire nations could become uninhabitable due to rising seas or desertification, forcing billions to migrate. Overwhelmed borders, resource shortages, and cultural clashes could lead to global unrest. Climate-induced migration and resource scarcity could exacerbate tensions, leading to war and the breakdown of governance. Unchecked emissions could lead to the depletion of breathable air in some regions, forcing humans to live in artificial habitats. While these are speculative, they illustrate the potential worst-case outcomes if humanity fails to act. Asteroid impacts are one of the few apocalyptic scenarios that are scientifically plausible. These events, while rare, have the potential to cause significant destruction and even mass extinctions. Understanding the history of asteroid impacts, the risks they pose, and the measures in place to prevent them provides insight into humanity's ability to address this existential threat. Asteroids are rocky bodies that orbit the sun, ranging in size from small boulders to massive objects several kilometers wide. While most reside in the asteroid belt between Mars and Jupiter, some venture close to Earth's orbit. When these objects collide with Earth, they can cause immense damage. Approximately 66 million years ago, a 10-kilometer-wide asteroid struck the Yucatan Peninsula, creating the Chicxulub crater. The impact released energy equivalent to billions of atomic bombs, triggering wildfires, tsunamis, and a nuclear winter effect. This catastrophic event is widely believed to have caused the extinction of 75% of Earth's species, including the dinosaurs. To the risk today, asteroid impacts on the scale of the Chicxulub event are exceedingly rare, occurring roughly once every 100 million years. Smaller impacts, however, happen more frequently and could still cause significant regional damage. Tunguska event, 1908, a smaller asteroid or comet exploded over Siberia, flattening 2,000 square kilometers of forest. The energy released was equivalent to 10 to 15 megatons of TNT, but the remote location minimized human casualties. Chelyabinsk event 2013, a 20-meter-wide meteor exploded over Chelyabinsk, Russia, injuring over 1,500 people and causing widespread property damage.
It came out of nowhere, a bright speck in the sky, soon streaking across the horizon, followed by an almost apocalyptic scene, a blinding flash of light, and then all hell broke loose. Dizzying explosions, shattering windows, knocking these office workers to the ground. These students were lucky, protected by curtains from the flying glass, and these men barely escaped the blast. In the streets, pandemonium. Terrified residents thought the world was ending. People started to panic. Somebody screamed, "The end of the earth," he says. The chaos of the meteor was captured on cell phones and on dashboard cameras of cars, so popular here in Russia. The blast was so powerful it knocked down a wall at this factory. In all, over 1,200 people were injured, mostly from broken glass. 3,000 buildings damaged, over 1 million square feet of glass shattered.
Given the global nature of the threat, international collaboration is essential. The United Nations established the International Asteroid Warning Network, IAWN, and the Space Mission Planning Advisory Group, SMPAG, to coordinate efforts in detecting and responding to asteroid threats. While Hollywood films often depict asteroid disasters in exaggerated ways, real-world scenarios are far more manageable with proper planning and technology.
Somebody dial 911! What hit us?
Small asteroid fragments.
This morning. How big were those?
Those were nothing. The size of basketballs and Volkswagens.
This new one you're tracking, how big?
It's the size of Texas, Mr. President. It's what we call a global killer, the end of mankind.
Advancements in detection, prevention, and international cooperation provide hope that humanity can protect itself from such threats. The sun, the star at the center of our solar system, is both the source of life on Earth and the determinant of its eventual demise. While the sun's death is billions of years away, understanding this process helps us comprehend the life cycle of stars and the long-term future of our planet. The sun is a main sequence star, meaning it is in the stable phase of its life. This phase involves the fusion of hydrogen into helium in its core, which generates the energy that powers the sun and sustains life on Earth. Currently, the sun is approximately 4.6 billion years old, about halfway through its 10 billion year lifespan. During this phase, the sun maintains a relatively steady output of energy, supporting a habitable climate on Earth. However, as the sun ages, changes in its core will set off a series of dramatic transformations. The death of the sun will be a gradual process, taking billions of years. Here's what scientists predict will happen. Hydrogen depletion. 5 billion years from now, the sun will exhaust the hydrogen in its core, causing the core to contract under gravity. This contraction will increase the core's temperature and pressure, initiating the fusion of helium. Red giant phase. 5 to 7.5 billion years from now, as the core contracts, the outer layers of the sun will expand significantly, transforming it into a red giant. The sun will grow so large that it will engulf Mercury, Venus, and possibly Earth. The intense heat will vaporize Earth's surface, rendering it completely uninhabitable. After the red giant phase, the sun will shed its outer layers, forming a beautiful but short-lived planetary nebula. Helium fusion and core collapse. The sun will briefly burn helium, producing heavier elements like carbon and oxygen. Once the helium is depleted, the core will collapse further. White dwarf formation. The remaining core will become a white dwarf, a dense, Earth-sized remnant composed mostly of carbon and oxygen. This white dwarf will gradually cool and fade over billions of years. Eventually, the white dwarf will cool to the point where it no longer emits significant heat or light, becoming a black dwarf. However, this stage is purely theoretical. Long before the sun becomes a red giant, its increasing luminosity will gradually heat Earth, causing the oceans to evaporate and making the planet uninhabitable in about 1 billion years. If humanity survives that long, it would need to find a way to escape Earth and possibly the solar system. Colonization of other planets or exoplanets in distant star systems could be a solution. The death of the sun is an inevitable cosmic event, but it is so far in the future that it poses no immediate concern for humanity. However, the process raises questions about the long-term survival of life and civilization. Nuclear war. The proliferation of nuclear weapons poses a threat to global security with the potential for large-scale destruction. Pandemics. Emerging diseases, especially those exacerbated by globalization, could result in apocalyptic-scale loss of life. Artificial intelligence. Some futurists warn of AI developed beyond human control, potentially posing existential threats. While science acknowledges these risks, it also provides solutions. Advances in technology, international cooperation, and proactive measures can mitigate or even prevent many of these scenarios. Philosophically, the idea of an apocalypse forces us to confront questions about existence, purpose, and morality. Some argue that focusing on apocalyptic fears distracts from addressing current challenges. Others see the apocalypse as a metaphor for personal and societal transformation, a call to reimagine our priorities and strive for a more sustainable future. Notably, the idea of an apocalypse often reflects human fears about change and the unknown. In this sense, it might be less about a definitive end and more about the end of the world as we know it, a transition into something new. Will it happen? Whether the apocalypse will actually happen depends on how one defines it. If we consider an apocalypse as the complete annihilation of humanity, science suggests that such a scenario, while not impossible, is improbable with proper stewardship. On the other hand, if we view it as a transformative event, whether personal, societal, or environmental, then smaller scale apocalypses are already happening. Ultimately, the apocalypse may not be an inevitable event, but a concept that challenges us to think critically about our actions, beliefs, and the legacy we leave for future generations. Instead of fearing an end, we might better focus on how we can shape a world worth living in, today and tomorrow.
Kasih dia.